Today's video will explain how to refactor a program into the separation of concerns. Hello, I'm James Helfrich. Separation of concerns involves separating a class into the three main concerns: the interface the client utilizes, the business logic, and the storage where all the attributes reside. This video will explain how to do this with an existing program, in this case, the game of chess. We'll start with the existing interface. Then we're going to pull out the storage, which is where all the attributes go. And finally, we move all the business logic into a separate set of classes. Okay, let's take a look at our original design for the game of chess. We're going to have a board class, which is going to contain a collection of public methods, which we're not going to really worry about right now. And then we're going to have a piece class. Now, this piece is going to know its position on the chessboard, the last time it moved, the number of moves it has, and what color it is, namely whether it's black or white. And of course, I'm going to have a collection of public methods. I want to know the type of piece. Is it a bishop, a rook, a pawn? I want to be able to display the piece, get the number of possible moves. I want to know if I'm white, and I want to be able to update its position. Now, of course, the board is going to have several different pieces, so that's going to be by aggregation. But since the board is going to create and destroy the pieces, we're going to use the composition form of aggregation. So we use the filled diamond, and there's going to be exactly 64, which means the board class must needs have a 64 piece array. Notice how I'm going to have the pure virtual function get moves as well as display as well as get type. Piece is going to have a position class by composition. It's also going to return a piece type, so it's not going to have a piece type, it just return one, and it's also going to return a move, well, a collection of move. Now observe that the piece class has three pure virtual functions: get type, display, and get moves. And so therefore I must have, well, a rook by inheritance, and a knight, and a bishop, and a pawn, and a space, and a couple other ones as well. Okay, each one of these must implement get type, display, as well as get moves. Okay, so this is my traditional and straightforward implementation. Observe that the piece class and its derived classes both have a public interface for a board, contains the logic, namely get possible moves, as well as his attributes, namely position, last move, num moves, and is white. Now, what we'd like to do is separate this into the three concerns. Okay, so my first step is I'm going to create a class called piece storage, and it's going to have four attributes: position, last move, number of moves, and is white. Let's do that real quick. Okay, the first thing I'm going to do is I'm going to take my piece class and I'm going to copy these four attributes and make a piece storage. Now I'm going to compile it to make sure it works, and it does. Okay, now that I made the piece storage class, the next step is to get some getters and setters for my position, set move, number of moves, and stuff like that. In other words, these are private attributes, so I have to give access to them. Notice how I'm doing things in the smallest possible chunks. I'm not impacting my piece class at all quite yet. So here I'm just going to add some getters and setters, super straightforward. I'm not going to really do any processing or validation because all those will happen in the business logic, which is coming up right now. So this should be super, super straightforward. Okay, I've done the minimal amount of work possible. I'm going to compile it. It still compiles, and I haven't broken anything yet, which shouldn't be surprised because I defined a class that doesn't actually do anything. Okay, the next step is I want to hook piece storage up to piece. And this association is going to be a horizontal line, but what is the type of association? It's going to be composition. And how many is there going to be? There's going to be exactly one. So let's do that work real quick. All right, I'm going to compile it to see if it works. All right, now that I hooked up the attribute, but I haven't actually used it yet. So the next thing I got to do is remove the protected attributes from the piece class and instead use my storage. And this can require a bit of work because everyone who references those attributes now has to change. So I'm going to have to do quite a bit of work to search and replace each one of these, and I'm going to do them one at a time. So I'm going to start with is white, and so I got to change it from f is white, which is my attribute, to storage dot is white, which is my method call. And I'm going to use the compiler a lot to do this. It's going to catch all my errors because once I remove the attribute, a compiler error will show me where the missing call is. Okay, I got one moved is white, and I have to do the same thing for num moves. So I'm just going to remove the attribute, I'm going to compile it, and all the compile errors will show me where I need to go to change the attribute reference to the method call reference from storage. All right, just a couple more to go here. Last one, I got position and last move. Let's do last move. All right, just the position is last one. Now notice that position is the hardest one, so I'm going to save it for last. In other words, I really understand how to change these attributes with the easier ones before I tackle the bigger one. And position is the hardest one because I reference the position of the piece many times. So there's going to be dozens of different references, but all the references are going to be changed the same way. I'm going to go this dot position to this dot storage dot get position, and that's going to be a copy paste in many, many different locations. Okay, it took a bit of work to find all the direct references to the position attribute. I had to replace it with the method get position, but now the method get position in the piece class will then refer to storage dot position, so that's going to work. Okay, notice that my piece class now only has a single attribute called storage of a type piece storage, and all the attributes are now in my piece storage class. So now I've separated the storage concern. What am I going to do next? Well, I need to separate the business logic concern. And the first step to that is to create a piece logic class and then do it all by itself. It's not going to be related to anything. So let's do that first tiny step. And of course, it builds and succeeds because I really didn't do that much. It just created an empty class. But remember, I always want to do things in the smallest chunk possible. So if I make a mistake, the mistakes are as easy to find as possible. Okay, now that I created my piece logic class, I want to give a piece storage that's going to link to it. And its link is going to be association, but that association is going to be composition, and there's going to be exactly one. Let's do that change. And of course, it still works. I haven't really done a lot of work. All right, now that I have this piece storage working, the next thing I want to do is be able to have the piece class access the piece storage, but now it's going to go through the piece logic, which means I have to have a bunch of pass-through methods. Get position, update position is white, set last number of moves, everything that I had in the piece storage is going to pass on through because the piece class needs to have that exact same information. So basically, I'm going to copy paste the code from the piece storage and put it in the piece logic. And then from there, I'm just going to change the references to storage dot get white and stuff like that. Okay, let's see if those work. They do. I haven't really done anything yet. Now, I want to emphasize again and again and again, I'm trying to do the smallest amount of work with each iteration so that if I make a mistake, I could really narrow it down. Okay, so my piece logic is now connected to piece storage. It doesn't do anything. It just passes through the request. It's kind of a shell, but that's okay. It's going to do more work later. But now I want to go into the piece class and I want to have a member variable called piece logic, which is going to be an association to piece logic, but that association is composition and to be exactly one. Now I'm going to do a little bit of thinking ahead here because I know that piece logic is going to be polymorphic because I know that all the different get moves are going to go into the business logic section of this class. Therefore, I want to have a pointer to a logic rather than an actual instance. We're going to have to allocate it with new and delete it with delete. So I'm going to do that work right now. Okay, I've created my pointer to a logic. I've allocated it in my constructors, and I will destroy it in my destructors. When I build, I still succeed. Everything works exactly as before. That's a good thing. Okay, now I have to actually remove my storage. So now anytime I want to access an attribute of the piece, I have to go through piece logic to do it. And that's kind of the whole point of linear composition is that I don't have a direct reference between the interface and the storage. All things go through the business logic. So I'm going to make that change right now. And this mostly consists of changing storage dot to p logic arrow, which is actually kind of straightforward. Okay, that was a lot easier than I expected. I got it right the first try. Okay, so far the only thing we've really done here is that we have put this intermediate step business logic, which doesn't really do anything. It's just going to pass through. But now what we got to do is move the actual logic from the piece class into my piece logic. And what's that going to consist of? Well, I want to create a pure virtual function called get moves. And this is going to correspond to the piece colon get moves. But when I do that, then I'm going to have to create a business logic derived class because that's a pure virtual function. And if I have a pure virtual function in a class, that makes an abstract class. Therefore, I cannot instantiate a piece logic. So I'm going to create a business logic class right now. And it's going to be a derived class from the piece logic. And it's going to implement a get moves, which at this point in time is going to be empty. Now notice I can no longer allocate a piece logic because, well, it's an abstract class. So now I'm going to have to make this a bishop logic. Okay, everything has worked so far. So now that I created the bishop logic, I got to do the same thing for the king, and I'm going to do that for all the other different pieces. And right now, these are just placeholders. They don't actually do anything. Remember, all the work is still done in the piece class. I haven't moved the code over yet, but I will do so shortly. So I'm going to start by taking this bishop logic and I'm going to copy paste it and make these 7 different variations for the 6 different pieces and the space. So I got to make sure I have an empty get moves method for each one. All right, it succeeded. It worked. So now I've created each of the derived classes. Now, what I'd like to do now is migrate over the get move slide and get moves no slide from the piece class. The get move slide is for all the sliding pieces, which would be the bishop and the rook and the queen. And the no slide is the pieces that don't slide, like the knight and the pawn and the king. Now, of course, the pieces should not need this. The piece logic should need it. So I just got to migrate that over. Then I'll be able to do the get moves functions from the piece classes themselves. So let's do the get move slide and no slide. All right, that one pretty easy. It's a lot easier to add code than remove code. So now I'm going to try to remove those get moves no slide. But in order to do that, I also need to get rid of the knights get move, the pawns get move, and all those, and move those over to the knight logic, the bishop logic, and so on. And then I have to change the piece get moves to a non-virtual function, and it will call the piece logic. So this all has to be kind of done at once. Because if I do one step at a time, I'm going to get a compile error, and I don't want that. So let's see if we can do that. So first I'm going to change the rook.getMoves to rooklogic.getMoves and so on. And that's just a matter of changing the association. And then I'm going to go into the class definition themselves. Instead of having an empty getMoves, it's just going to be a prototype because it's going to be defined in a C++ file. Okay, there's one last thing I need to do. Right now, we're always allocating a bishop logic, but I don't want to do that. I only want to allocate a bishop object if I'm in the bishop class. So I'm going to have to say p logic is null pointer right now, and same here. And then my space is going to allocate p logic equals new space logic and do the same thing for my pawn and everyone else. All right, there's one last thing I need to do, and that is I need to pass the row and column into my logic so we can pass it on down. And I don't have a constructor for that. So I need to add that constructor to each of my instances here. Now notice I have to not only change where I call the constructor from, but I also got to add a new method to my piece logic base class, which takes not only is white, but a row and column as well. And then of course I have a myriad of little compile errors I have to fix while I'm going through this, and that just takes a minute to tidy this up. There we go, got the last couple in there, got to have an is moved, and I think I'm ready to go. Yeah, and it compiled, good to go. I have taken all the business logic out of the interface, which is the piece class. And now the only thing the piece class does is it interfaces with the chess game, which means it has to be able to know its position and the color of the piece and stuff like that and the type of the piece. All the business logic, namely how chess pieces move, is in the piece logic and its derived classes. And of course, all the state is stored in the piece storage. So now we have separation of concerns and we integrate it using linear composition. We can learn more about separation of concerns in the separation of concerns chapter of the software design textbook.